Software used to be, well, pretty boring. You'd click a button, it executed a command, and you just sat there waiting. But guys, we are crossing a massive technological threshold right now. Software is literally waking up. It's no longer just a static tool you use, it's becoming this autonomous agent that actively acts on your behalf. We're talking about systems navigating the web, sending messages, organizing your data, and actually making independent decisions. Welcome to this explainer, where we're going to unpack the explosive reality of autonomous AI agents.
Okay, so to really grasp where we're at, we got to look at the foundation. AI researcher Andrej Karpathy actually described OpenClaw, which is the original open-source AI agent framework that kind of kicked off this whole revolution. He called it a 400,000 lines of vibe-coded monster. And honestly, that description, it hits the nail on the head. It tells you everything you need to know about the ambition and just the sheer complexity of giving AI a physical body to interact with our digital world. It's incredibly powerful, but it's also resource-heavy, super complex, and frankly a bit intimidating.
So here's our roadmap for this explainer. We're going to start with the OpenClaw monster, then look at splitting the agent ecosystem, move into smarter self-evolving agent brains, touch on coding the AI soul, compare rules versus core values, and finally wrap up with the autonomous software future. Let's jump right in.
All right, Act 1, the OpenClaw monster.
Let's take a look at the physical infrastructure, the body of these agents, so to speak. OpenClaw is basically a perfect example of sheer contrast. On one hand, its capabilities are absolutely wild. We're talking connecting to over 15 messaging platforms, WhatsApp, Discord, Slack, you name it, and tapping into a community marketplace of over 5,700 skills. It can literally manage your Gmail, control your smart home devices, and automate GitHub workflows. But, yeah, there's a big but here. These superpowers come with some massive costs. Running this monster requires over 1 GB of RAM, has incredibly slow startup times that can hit 500 seconds, and comes with documented security risks, like exposing shell access right out of the box. So it's an absolute powerhouse for sure, but it is heavy and incredibly demanding on your hardware.
Which brings us to Section 2, splitting the agent ecosystem.
Because OpenClaw is such an absolute behemoth, developers quickly realized that, one size definitely does not fit all here. The ecosystem actually fractured to solve those exact resource issues. Instead of everyone relying on this one massive framework, developers started building highly specialized bodies. You still have OpenClaw acting as a full 400,000-line platform, but then you have these crazy optimized alternatives, like ZeroClaw, which is built entirely in Rust and operates on less than 5 megabytes of RAM for edge computing. Or look at NanoClaw, stripped all the way down to just 500 lines of code, focusing entirely on maximum security using operating system-level containers. The ecosystem essentially split to offer the exact type of body you need for your specific use case.
Now, this split also created a really interesting divide in how we actually deploy these things. On one side, you've got power user control. This is your OpenClaw setup, where you install it locally, manage the servers, handle your API keys, and retain total data sovereignty. On the flip side, if you just want cloud speed, you've got managed solutions like MaxClaw or Space Agents. With those, you literally just click a link, and boom, your agent is live in a browser tab in under 10 seconds. It's the difference between building a custom sports car in your garage versus just swinging through a drive-thru. If you want instant speed and zero setup, you go to the cloud. But if you demand absolute privacy and control, you build locally.
Moving into Act 2, Section 3, smarter, self-evolving agent brains.
So we built these incredible bodies, right? But a capable body is totally useless without a functioning brain. And for all their raw power, standard AI agents have some pretty critical built-in weaknesses. First up is massive token waste. Every single time they face a task, they reason from scratch, just burning through expensive API tokens. Second, they suffer from repeated costly failures. They literally make the exact same mistakes over and over because they don't have a mechanism to share solutions. And third, there's silent skill degradation. As websites change or external tools update, the agent's static code just breaks. Historically, agents just didn't learn from experience at all.
But what if they could actually learn from their mistakes? Well, enter a framework called OpenSpace. It acts like this dynamic, self-evolving brain that you can just plug right into any agent body. And it gives these agents 3 distinct superpowers. Step 1, autofix. When a skill breaks, the agent autonomously analyzes the failure and instantly repairs its own code. Step 2, auto-improve. It takes successful tasks and refines the patterns so they're even faster the next time around. And Step 3, auto-learn. It literally captures winning workflows from actual usage and saves them as brand new, perfectly reusable skills.
And the impact here on real-world business and productivity? It's staggering. When an agent actually stops repeating the same dumb mistakes and starts evolving its own skills, the results are off the charts. In rigorous professional economic benchmarks, agents equipped with this self-evolving open-space brain earn 4.2 times higher income on tasks compared to standard, non-evolving agents using the exact same underlying AI model.
And here is the absolute kicker. It achieves those far superior results while simultaneously cutting 46% of costly tokens. Let me say that again. Almost half the cost. Because the agent isn't reasoning from zero every single time, because it's actually reusing an optimized, evolved skill that it previously learned, it does way more complex work for significantly less money. It completely turns these AI agents from fun little novelties into highly efficient, economically viable digital coworkers that actively save you cash.
All right, on to Act 3, Section 4, Coding the AI Soul.
As these digital coworkers get more and more capable and autonomous, a really massive question comes up. How do we actually make sure they do what we want them to do, safely? You can't just give an AI a blind command to maximize utility. That's how you get sci-fi disaster movies. It needs profound nuance. So, Anthropic, the team behind the Claude model, tackled this by writing a literal 80-page constitution. It's a foundational document of core values used to align the AI's behavior and purposefully shape its ethical persona. It explains to the AI why it should behave a certain way, giving it deep context rather than just slapping on a rigid list of hard-coded prohibitions.
But you might be wondering, how does the AI prioritize those values when they inevitably clash? Well, Anthropic established a 4-tier hierarchy. The AI has to constantly balance this during every single interaction. First, at the foundational base, it must be safe. It cannot undermine appropriate human oversight. If it passes that safety check, it moves up to Tier 2, ethical, requiring virtues like honesty and genuine care. Above that is Tier 3, obey specific Anthropic guidelines. And finally, way at the peak, it must be helpful to the user. Notice that being helpful is intentionally the lowest priority. If a user asks for something unsafe, like say instructions to build a bioweapon, the AI relies on this foundational hierarchy to refuse the request, prioritizing broader safety and ethics way above blind obedience to the user.
Which leads us to Section 5, Rules versus Core Values.
This layered, values-based approach is such a fascinating departure from how we've historically thought about programming machines. I mean, for decades, our whole cultural expectation of AI alignment came straight from sci-fi. Think Isaac Asimov's 3 Laws of Robotics. Those were rigid, rule-based commandments, right? Like, a robot may not injure a human being. But in practical reality, rigid rules fail because they completely lack necessary context. They often lead to super-literal, catastrophic interpretations by the AI. Anthropic's constitution, however, relies on contextual, layered, values-based guidance. It treats the AI almost like a reasoning entity that needs to deeply understand the spirit of the law, not just blindly follow the letter of it.
In fact, researchers analyzing this document noted that the Constitution acts more etiquette guide than prohibition list. It's not just boxing the AI in with a bunch of do-nots, it's actively teaching the AI how to be a helpful, authentic, and safe persona navigating our super complex human world. It is quite literally a philosophical treatise embedded directly into working software.
Finally, Section 6, the autonomous software future.
So, if we zoom out and put it all together, we've got the specialized physical body, the self-evolving brain, and this values-driven soul. And guys, this leads to a profound paradigm shift. We are literally no longer just coding software, we are cultivating autonomous digital workers. You don't just write a static script and run it anymore. You deploy an agent, you give it a high-level goal, you let it self-evolve its own tools to solve problems, and you guide its overarching behavior through a constitution of core values. It is just a completely new era of computing. Which leaves us with one final, pretty provocative question. When software becomes an autonomous coworker, capable of learning, acting, and evolving entirely on its own, are you the manager directing the work, or are you just the audience watching it happen? As these AI agents get faster, smarter, and way more independent, our fundamental relationship with technology is changing forever. And that is a wrap on this explainer. Keep exploring, stay intensely curious, and definitely start thinking deeply about how you're going to manage your new digital team.